analytical instrument. So that's why I invite you to give us the speech about the HPLC analysis. The vitamin is tắc ký lỏng, áp suất cao. So I think the topic of this today is very useful for us when we are the biotechnology engineer. So we have to use some analytical instrument to analyze the sample that contains some bioactive compound like phenol or some phenolic compound. I think that okay, now our class not enough today. Okay. Anyway, please welcome Dr. Saga.
Yeah, thank you.
Okay, your turn.
Okay, thank you for your kind introduction. So I'm pleased to give you talk on HPLC. So I would also like to thank all the event members that are involved to have this talk. So let me share my screen first. That option is not working, sharing screen.
Wait for me.
Only meeting organizers can share the screen.
I see. Yeah, okay. I give you the access for sharing the screen.
Now you can see my screen.
Let me see. Yeah, okay.
Yeah, you can see it as a full screen, right?
Yeah, that's what.
Okay. Am I clearly audible? Am I audible to all of you?
Let me see. It's okay.
Can you hear me clearly?
Yeah, okay. Very
Okay,
clear.
okay, let's get started.
Yeah.
So once again, I would like to thank you, Dr. Chi. And as we have a lot of memories, so he worked in Taiwan with me. So as he mentioned, and he is very hardworking student during PhD. I can still see it. So thank you inviting once again. So I will start the talk. So the today's topic is high performance chromatography. So we also called it as high pressure liquid chromatography or high performance liquid chromatography. In short, it is HPLC. So what I will go today, so I will introduce the HPLC instrument, what are the different components of the HPLC and how to use this instrument for analysis of different types of compound. So this is the outline for today's talk. So as I mentioned, I will introduce everything about this analytical technique, then talk about the different components of HPLC. And I will also shed some light on the types of liquid chromatography. What are the types we have and how we use that for different types of analysis. Then I will also talk to you about HPLC detector. What are the detectors we should use for the different types of compound? And then we also have different types of column. So that gave us a freedom for the analysis of different types of compounds, whether it is organic, inorganic, or conjugated compounds or different types of compound, then how we actually do the analysis in laboratory. So I will also talk about that. And then very important thing that during method preparation, the method we use for the analysis, there are two important factors, that is temperature and flow rate. So how it related to the analysis of our compound, that will also talk, I will also talk about that. And then what are the advantages of HPLC? So, okay, so we know many forms of chromatography, right? The liquid chromatography and gas chromatography are very common and well known to all analytical scientists. So here I have shown you the most advanced instrument of HPLC. So if you go to advanced laboratory, so you can see the HPLC instrument like this. So it is highly advanced HPLC instrument. So it has an auto sampler and different components that I will talk you later in the presentation. And then this is a gas chromatography. So left side is a HPLC and right side is a gas chromatography. So these two chromatographic techniques are highly important for the analysis of different types of compound. So today I will talk about the HPLC. My talk is only limited to HPLC and how we use this instrument for the analysis of complex compound. So, okay, so before going into the HPLC, details of HPLC, it is very important to understand the principle of HPLC, how it works. So to understand the principle of HPLC, we first look at the principle behind liquid chromatography. So what is liquid chromatography and what is the principle of liquid chromatography? So you can see here in liquid chromatography, the separation of component takes place between two phases. Okay, in liquid chromatography we have two phases. One is stationary phase. Here we have a stationary phase. We have a column which is packed with the stationary phase. Either it is alumina or it can be a silica. And then we have a mobile phase that we introduce over here, right? So this is a type of liquid chromatography. So what is stationary phase? The substance on which the adsorption of the analyte take place. So that is a stationary phase. It can be solid, gel or solid liquid combination. Then we have a mobile phase that we'll introduce over here. So mobile phase is basically a solvent which carries the analyte. Okay, it is a solvent which carries the analyte. What is analyte? Analyte means our sample that we are interested in the analysis. Okay, so the mobile phase will carry our sample through this stationary phase. Okay, then you can see here the chemical mixture is passed. So we have this red color mobile phase and this is our sample and this is a stationary phase. When we pass mobile phase, the sample will pass through the mobile phase and separation happens. So you can see there is a separation happening. Okay. So you can see here the chemical mixture is passed through the column of adsorbent material with the help of mobile phase and the mixture is get separated into individual components. Okay. This is a liquid chromatography, but it had a bigger problem. So what is that problem? The problem with liquid chromatography, it is a time consuming. It takes a lot of time to pass through this sample through this column. So it is a time consuming. Okay. And the resolution is not good. So to solve this problem, we are using HPLC. So what we are doing in HPLC, HPLC is basic this same chromatography, liquid chromatography, but we are passing this mobile phase. We are passing this mobile phase with a high pressure pump. That means we are increasing the speed of the mobile phase through this column. That is basically HPLC. HPLC is nothing but a liquid chromatography, liquid column chromatography. We are just passing the mobile phase with the help of pump through this column. Okay, so that is HPLC. So why we want to do this? Because by doing so, we can solve the problem of liquid chromatography. That is, it is a time consuming. So if we pass the mobile phase very fast through this column, we can do analysis within few minutes. Okay, it requires 2 or 3 days. Okay, but by using HPLC, we can do same analysis within few minutes. So that is the benefit of HPLC. And we can also do this analysis. With lower time, and also we can improve the efficiency of the analysis. So the HPLC is a modified form of column chromatography, we can say. So in this case, we have to connect the high pressure pump to the column. So here I have shown the pictorial diagram. So how HPLC will look like. So we have like column, then we pass the mobile phase through the column, the high pressure pump attached to the column. Then another benefit and another modification we have in HPLC, we are using the stationary phase with a small particle size, and it will give us a large surface area, and that lead to a higher resolution. So the HPLC is a technique that employs a liquid mobile phase. Stationary phase are typically a chemically modified silica or polymeric beads packed into the column. And in HPLC, the separation mechanism that partitions component of sample is based on the nature of sample. So this is very important that we have to understand how separation happens. The separation happens based on the nature of the sample and the type of the mobile phase and the type of stationary phase that we use. So these are three factors: what type of sample we are using, what type of mobile phase we are using, and what type of stationary phase we have. So that all three work together and will give us a good separation. And I will tell you later in the video how to choose a good mobile phase, a stationary phase, according to our sample, so that we can have a good separation and high resolution. Okay, let us see the components of HPLC. Now you know the HPLC is basically a column chromatography, but what we are doing, we are just passing the mobile phase through the column with the help of pump, so that we can do analysis very fast and increase the resolution of our analysis. And so what are the different components of HPLC? So HPLC has many components as I listed here. So it comprises degasser, then we have a pump, then injector, then column. The column is basically kept inside the column oven. Then we have a detector and a recorder. So I will explain the importance of each component. So first what we do, this eluent is also called as mobile phase. We pass through the pump. But before passing, what we have to do, we have to pass this eluent through the degasser. So what is the role of degasser? Because the mobile phase we use for analysis may contain some gases, may have some gases, say for example, oxygen and other gases. So that is not good for our analysis, because that can create a bubble in this line, because we are using small line here that will take mobile phase into pump and then to the injector. So if the mobile phase has a gases inside it, like oxygen, some trapped gases, then there is a chances that bubble will form in this line. So to get rid of this kind of problem, we have to degas our mobile phase before passing into the pump. Okay. And one more important thing I have not shown here. We usually do the sonication of mobile phase before using it for an HPLC. So by using sonication, we can remove the gases that are soluble in the mobile phase, and then for more precaution, we are passing this mobile phase through degasser, and then it will go to pump. Okay, so this is the role of degasser. The pump, what is the role of pump? Pump generate a flow of eluent from solvent to reservoir. So this is a solvent, and the pump will flow our mobile phase towards the injector, or we can say towards the column, with a constant flow and constant pressure. So it will monitor, we can monitor the flow and pressure using the pump. Then we have an injector. So injector is placed next to the pump. The sample is injected. The sample we are interested in the analysis that we inject in the injector. So we inject the sample actually manually, but in advanced instrument, we have auto sampler. We don't have to inject the sample. The instrument will inject the sample for us. But most of the instrument, we have to inject the sample manually with the help of syringe. Then we have this column and oven. So column is actually made of a stainless steel, and it is usually kept in the oven. Why we are keeping this column in oven? Because we want a constant temperature for the analysis, and sometimes we also need to change, or we also have to do the analysis at different temperature. For example, certain column required to operate at 80 degrees Celsius. So if it is kept in oven, we can monitor the temperature. Okay, then analysis actually happens in this column, and then our sample is eluted here, and then the sample which will come out from the column, which will be detected by the detector. We have a different types of detector, and then it will go to west. And once it is detected by the detector, and with the help of recorder, we can know, we can see how is the HPLC chromatogram. And using recorder, we can also do the integration. We can see the area under the peak, and we can also see how is the peak pattern and so on. So this is basically a different components of HPLC, and their how to say, how they work together, so that we can have finally good analysis, so that finally we can understand how using HPLC we can analyze the sample. Okay, so here you can see the pictures of few HPLC component in real life, how they look like. So this is the degasser that I talked to you in my previous slide, right? So this is a degasser. It looks like this, and it has an inlet and outlet. So one is inlet and another one is outlet. Similarly here, inlet and outlet. In this degasser, actually we can connect two inlets and two outlets simultaneously. The commonly used HPLC injector look like this. So this is the injector, and it is called as a Rihodine injector. This injector has a 6-port injection valve. It has a 2 position. You can see here it is a load position and the inject position. It has a 2 position. Basically, in load position, the sample is loaded in the sampling loop. So this is same injector. These two are the same. So this is just another view of the injector. It also the injector is connected to the sample loop. When we inject the sample, when we load the sample will be loaded in this loop. And in inject position, the sample is transferred to the column. The HPLC column will look like this. So these are the different types of column. As you can see in this picture, the column can be as small as maybe like 3 to 4 centimeter, as long as 20 to 30 centimeter. So this small column is actually also called as a guard column, and it is used basically to enhance the life of separating column. So these two are separating column, and this is a guard column, because if our sample has a very high concentration or some impurity, so that can hamper the life of column. So for that we have this small column to protect the life of this analysis column. So this is the different components of HPLC will look like. Okay, so this is very important. If you understand this, I would say you will understand the 90% of today's talk. So it is very important. So here I would like to show you the mechanism of 6-port injection valve. to understand the sample injection process in detail. So how we inject the sample and how it goes through the column. So when you understand this, you will understand everything, I would say. So this is a 6-way wall. You can see 1, 2, 3, 4, 5, 6. It has a 6 port, and this is inside the injector. So this injector has a 6-way port, which will look like this. So just for simplicity, I am showing this figure. So the central port is called sample injector. So this is the syringe. You can say we inject the sample here, then it will go to the sample loop. So this is the sample loop, and then it will go to the waste. So I will again show you in real life the sample loop like this. It will look like this. When we inject the sample, sorry, when we load the sample, it will go in this sample loop. So you can see here, we inject the sample here, sorry, we load the sample here, then it will go in the sample loop, and then it will when we if we inject the more sample, the additional sample will go to the waste. So this is a 6-port injection wall. So you can see here, now we know this 4-port. Okay, we load the sample, then it will go to the sample loop, and then finally the sample, which is maybe the capacity of this sample loop is 20 microliter. If we inject 30 microliter sample, the 10 microliter will go in waste and 20 microliter will remain in the sample loop. And here you can see the pump is connected to the column. So our mobile phase will go in the pump, and then it will go to this two port, and then it will finally go to HPLC column. So that means here you can see the mobile phase flows directly to the column. Okay, it is not connected to this 4-port. In this case, we don't see any connection of mobile phase with the sample loop. So there is no connection between mobile phase and sample loop. So red color is for mobile phase and blue color is for our sample. You can consider like this. Now next figure. Now I loaded the sample using the syringe. So for that I have to keep this injector in a load position. I will load my sample. The sample now in the loop. Okay. Here the sample is loaded in the sample loop, and even after loading the sample, you can see here it cannot pass through the column. Our column is here. It cannot pass through the column. Now after loading the sample loop, the wall is changed from load position to inject position. Now what I will do? I will change this wall from load position to inject position. Then what happens? You can see here. Yeah, this will happen. So when I change this wall from load position to injector position, what will happen? Oh, sorry. I think my PowerPoint stopped. Just give me a minute. I will open it again. Can you see my slide now?
Okay, I can see.
Okay. So now we are here actually. We loaded the sample in the sample loop. Now we are changing this knob from load position to inject position manually. We are doing this manually. Then what happens? You can see what happens. There is this connection will happen. This connection will break and there will be a new connection. You can see in next slide. So you can see now the mobile phase will pass through this way, and then it will take the sample present in the sample loop all the way to the column. Now our sample is going to the column. We injected our sample in the loop. Now the mobile phase passing via pump will take our sample and then it will go to the column, and then analysis will stop. So for next analysis, what we have to do? Again, we have to bring this wall to the load position, this position, and again inject the new sample. So this is the inject position. The wall is in inject position, and this is the wall in load position. And this sample then will go to the column, and then actually separation will happen in the column. This column is called as a heart of HPLC. So this is highly important. Actually, the separation of our sample is actually happens in the column. And then the detector will detect it, and through recorder we can see the HPLC profile. So finally, the injector position again change back to the load position for the injection of new sample or next sample. Okay, so now you know how this injector works. It is called as a Rihodine valve, and it has a 6 port. So it is 4 port is connected to the loop and 2 port is connected to the column, and that's how it works. So here I would like to talk about the types of liquid chromatography. So what are the liquid chromatography types and how they work? So first we have based on the elution technique. So how elution happens. So first one here we have isocratic elution. So what is this isocratic elution? So the isocratic elution, the mobile phase composition remains constant throughout the analysis. Then you can say isocratic elution. Yes, simply the mobile phase remain constant during whole analysis process. We can say isocratic elution. Then we have a gradient elution. In gradient elution, what happens? The mobile phase composition is changed during separation process. Sometimes we do need to change the concentration of mobile phase during analysis. If we can do that, then it is called as a gradient elution. So this is just a types of liquid chromatography. It can be a isocratic elution mode, or it can be a gradient elution based on the elution technique, based on the mobile phase. Then we have another type. So the gradient elution decreases the retention of a later eluting component so that they elute faster, giving narrower peak, and it improves the peak shape. Sometimes it is difficult to have a proper separation, good separation with isocratic elution. So we have to go for gradient elution. So gradient elution, what we can also this also offers how to say ability to control the polarity, which makes the separation of the mixture in a lower time. The gradient elution is good for the analysis of complex sample. Then we have the next analysis, liquid chromatography, that is based on the scale of operation. We have two types, analytical HPLC, then we have a preparative HPLC. It is very simple. In analytical HPLC, we cannot recover the individual components. In preparative HPLC, the individual components of the substance can be recovered. So here we cannot recover the sample. In simple words, here we can recover our sample after analysis. Then we have a next technique is based on the type of analysis. We have two types, qualitative analysis and quantitative analysis. So what qualitative analysis is? We analyze the compound in order to ascertain the nature of its chemical nature or chemical constituents. The separation of individual components is possible. However, we cannot assess the quantity here in this case. And in quantitative analysis, the amount and the proportion of its chemical constituents, the quantity of the impurity and the individual components can be measured. Then we have two more types based on the mode of analysis, normal phase and reverse phase. So in normal phase HPLC, in this case the stationary phase is a polar. In this case, the stationary phase is polar and the mobile phase is non-polar. So what are the most polar stationary phase? Silica. Silica is a polar stationary phase, right? And if we use polar stationary phase, then polar molecules are retained on the stationary phase, while non-polar molecules moves faster down the column with the mobile phase. And what is the reverse phase? We have to reverse everything. Here we are using polar stationary phase. In this case, we are using non-polar stationary phase and polar mobile phase. So the reverse phase is a stationary phase is non-polar and mobile phase is polar. So based on this, we have different types of liquid chromatography. Of course, all are HPLC, but just how we are using. So we have different names for that analysis technique. Okay, we have some more types based on the principle of separation, how separation happens. Okay, now previously is basically based on the what type of HPLC you are using, what type of mobile phase you are using, what is your purpose, qualitative or quantitative analysis. Okay, but there are types based on the principle of separation, how separation happens. So basically we have 5 types. First one is adsorption, partition, size exclusion, ion exchange, and affinity chromatography. So what is adsorption? In this case, we see the competition between liquid phase and solid adsorbent. The separation happens based on the adsorption. The separation of different compounds that are present in your sample happens based on the adsorption. It is called as adsorption chromatography. Then we have a partition chromatography. So it's like the principle of separation means separation is only happening based on the adsorption. In case of partition, what happens here? The stationary and mobile phase both are liquid. This is very interesting. The stationary and mobile phase both are liquid. For the separation of amines and alkaloids, partition chromatography is used. The partition chromatography is also called paper chromatography, and in partition chromatography, the special paper is used which contains water and acts as a stationary phase. Then we have a size exclusion chromatography. It is also called as a molecular sieving chromatography. In this case, the porous stationary phase allows the separation of the component based on their size. Then we have ion exchange chromatography. So in this case, the stationary phase is ionic and mobile phase is polar. The compounds that are efficiently ionized are analyzed using these columns. Means we just have ion exchange column kept in the HPLC. The separation of molecule occurs based on the attractive forces between molecules and the charged stationary phase. Ion exchange chromatography used in the separation of proteins, peptides, and nucleic acid. And last one, we have affinity chromatography. Here, the interaction between stationary phase and analyte is based on the lock and key mechanism. So I will just explain one in bit detail. So that is a size exclusion chromatography. So I will explain briefly size exclusion chromatography due to its main important application in polymer industry. So this chromatography, size exclusion chromatography, is a technique for measuring the chain length of other other characteristics of polymer by separating them based on their size. So if we use the column that works based on size exclusion chromatography in HPLC, then we call it as that instrument GPC, gas permeation, no, GPC, gel permeation chromatography. We call it, but it's same like a HPLC. The size exclusion chromatography is a type of HPLC, can be performed in wide range of solvent. In size exclusion chromatography, columns are packed with tiny round, this type of column. So it's basically a column which is packed with a tiny round porous particles such as spherical silica to separate molecules retained in the solvent that is passed through the column. It separates molecule based on their size, hence size exclusion name. You can see that during analysis, the large polymer will it faster. So these are the polymer. Okay, you have different types of polymer. If you pass through this column, the large polymer will come first. then medium size polymer, and then small size polymer. Why is small size polymer coming later? You will think, oh, this is small, it should come first through the column, right? But because of its smaller nature, it has a lot of obstacles inside the column. It the how I can say this is the small polymer have a more interaction with the porous stationary phase. Therefore, it takes longer time for the elution. The first size exclusion chromatography column were packed with the gel. So therefore, we also called it as a gel permeation chromatography, or in other words, GPC. So using this technique, we can determine the molecular weight of different types of polymer. If you have a sample which has a different concentration of different types of polymers, and you want to know the molecular weight and the type of polymer, you can use this type of HPLC or this type of chromatographic techniques. So here the separation is happens based on the size, not the adsorption, not how to say, not the affinity, not the ions, not ionic attraction. It's just based on the size. The smaller polymer will come later, the bigger polymer will come first. Now I will spend some time on explaining the HPLC detectors. There are many detectors used in HPLC depending on the properties of a compound that are used for analysis. The common detectors are UV, ultraviolet detector, RI detector, and mass spectrometry. The UV detector responds to a compound that absorbs light. If you have a compound with more conjugation, like aromatic compound and different types of functional group, and you can see there is a conjugation, then you can use UV detector. The UV detector responds to the compound that absorb light, and the UV detector are the most versatile and show high sensitivity. The UV detector are most versatile, and it is not used for compound without chromophore. If your compound don't absorb light, then we don't prefer this type of detector. Then next we have RI detector, uses a monochromator, and it is one of the least sensitive detector and extremely useful for detecting uh, compounds that does not absorb light or emit light. For example, sugar or alcohols, they don't absorb light. So for that type of analysis, we have to use RI detector. Then we have a fluorescence detector used for a compound that emit light. Then last one, we have a micrometry detector, is the most widely used in pharmaceutical labs, and it is capable of analyzing and providing the molecular identity of a wide range of compound. We can find out the molecular mass of the compound using this type of detector. Okay, now we know different types of detector. Now here I want to explain the different types of column that we have in HPLC. First one is a guard column. As I showed in my previous slide, it is very small column. This column is used to prolong the life of separating column, the main column where the separation happens. This guard column is packed before this guard column is placed before the separating column. It filters particle that can clog the separating column and removes compounds or ions that could cause baseline drift. So guard column must be changed regularly. And then we have a derivatization column. It involves chemical reaction between analyte and reagent to change the chemical and physical properties of the analyte. This column stabilizes the sensitive analyte. If our compound is not stable, then in that case we have to use this type of column. It helps to stabilize the compound while also it separates the different compounds from our sample. Then we have a capillary column. The capillary column diameter is less than millimeter, and it is also called as a micro column. Then we have a fast column. So actually this fast column is just we do the analysis very fast. The size of this column is smaller, shorter. So for simple analysis, we use this type of column. If you have only two compounds in one sample and which can be separated very easily, then we don't have to use another column. We can use fast column, small column, and we can do analysis quickly. We maybe within 3 or 4 minutes. Then we have analytical column. So in case of fast column, it increases the sensitivity, decreases mobile phase use, not only time. We can also decrease the use of mobile phase, right? By doing analysis faster. And analysis time. Fast column also increases the reproducibility. We can do maybe 2 or 3 analysis to see whether the results are reproducible if we can do it fast. Then we have analytical column. The analytical column achieves separation by different uh, intermolecular forces between solute and stationary phase and those between the solute and mobile phase. Then we have a preparative column. The length of this column is 10 to 15 centimeter and diameter is around 4.4 to 5 mm. And it has a pressure regulator and fraction collector. So, okay, how we do the actual analysis, okay, in the laboratory. So that I would like to show you here. So this is the important part. If you know the HPLC, it is just column chromatography. We are passing mobile phase with the help of pump. That's it, HPLC is. And then there is a injector and then there is a column and then detector will detect. But how we do the analysis, actual analysis in the laboratory, okay? So when you finish any reaction, okay, you will have some sample that you are interested for the analysis. Okay. So first thing what you will do, you will dilute the sample. The reaction mixture obtained after completion of reaction is first diluted using appropriate solvent. That again depends on what mobile phase you are using. Suppose if you are doing the hydrolysis of cellulose into glucose. Now you know the glucose is soluble in water. So after reaction, you will get some glucose and some side products, maybe fructose, glucose, and some side product. You want to find out how much is the concentration of glucose in your sample. So first thing, what you will do, you will take the sample, you will dilute it with water. Why water? Because glucose sugars are soluble usually in water. And for this analysis, we also use a mobile phase, that is water, so that it can easily take our sample to the column. So first, after you dilute your sample, then you have to do the filtration as I have shown here. The small quantity of dilute sample is passed through this 0.22 micron nylon syringe filter. So this filter is connected to the syringe here as shown in this picture. Then you can pass your sample through this syringe filter. So this filtration is performed to remove the solid impurities present in your sample. If you are using some solid catalyst, right? So we don't want any solid material to go inside the HPLC column. So to remove that, we are using this syringe filter. The size of this syringe filter is 0.22 micron. Okay. And then we pass this, then we have this sample. This is called as vial. It is one point around 1 ml vial. And the filtered sample is then injected in the HPLC. Oh, again stop. What is the problem? I don't know. Sorry. Just give me a few seconds. I will start again. Okay. So now we filtered our sample. Then we take this syringe. This is around 25 microliter syringe, and we take this sample and then we inject this sample in the injector that I previously showed. Then this sample will go in the injector loop, and then with the help of mobile phase it will go to the column. Then match the peak with standard. So if you are expecting after reaction you should get some glucose. So after injecting this sample, you also have to inject the standard sample of glucose, so pure sample of glucose in the HPLC, just to check, just for matching whether we are getting glucose in our reaction sample or not. And then we do peak integration to for quantitative analysis to find out the quantity or to find out the concentration of glucose in our sample. The area under the peak is directly proportional to the concentration of the sample in this case. So I will show you in more detail in this slide, on this slide. So now for unknown sample, how to understand the chemical composition using HPLC. So here you can see first we have injected, let us suppose we have injected the standard sample based on the expected compound. We expecting glucose. So I injected glucose. The retention time is 5 minutes. Okay. Then I also injected sucrose. So I also expect maybe in my sample there may be a possibility of sucrose. The retention time for sucrose is 8 minutes, as you can see here. And then this is the analysis of unknown sample that we injected to find out what are the different products are formed in our reaction. So you can see if there is we have a peak around 5, okay, that means we also have a glucose. It correlate with the standard glucose. So this shows that in our sample we have a glucose. But these are two unknown peak that we don't know, because it is not matching with the sucrose, and it is we don't know, there is one more additional peak. So for these peaks we also have to inject additional standards, maybe fructose, or maybe if there is some dehydration reaction possible, HMF and so on, and find out what are these two unknown peak. But with these two standard we can find out that in our sample there is a glucose. Okay. Now how to find out the concentration? We can calculate the concentration of glucose present in unknown sample by performing calibration of glucose standard at various concentration. So we have to inject this glucose at a different concentration as I shown here. So I injected a different weight percent of glucose, like 0 without glucose. We have 0 area, then 0.2 gram glucose, then 0.4 and 0.6, then we will get a calibration curve. So this calibration curve we will use to find out the concentration of unknown sample in our sample. So I would suggest here to do at least 4-point calibration curve for higher accuracy. And from this equation, we call it as y is equals to mx plus c. From this equation, the equation of slope, we can calculate the glucose concentration in unknown sample. And this is how basically we analyze the sample using HPLC and find out which compounds we have in our sample, and also find out the concentration of sample. Okay, so here I would like to show you two important points. That is, what is the effect of temperature on our analysis? Because we are keeping the column inside the oven, and we have this flexibility that we can change the temperature of column. So here is the same analysis performed at different temperature, as you can see here. So with an increase in temperature, like from 50 degrees C to 100 degrees Celsius, the column pressure decreases. You can see the pressure of column decreases. With increase in temperature, the pressure of column decreases. Aside from this, the higher column temperature decreases the analysis time. You can see for this we have to wait for 21 minutes. But if we increase the temperature to 100 degrees Celsius, we can do analysis maybe in 11 minutes. So we can save our 10 minutes. Okay. So this is highly important. And one more important thing, the optimum column temperature is essential for the proper separation of peak. You can see for a lower temperature, the peak separation means the peaks having a tailing, the peaks are not sharp. Also, it takes a lot of time for the elution. But for higher temperature, the peaks are very sharp. And also it takes lower time for the elution. So you can notice that the lower column temperature leads to peak tailing here and higher retention time. So it is very important when you do HPLC analysis to optimize the temperature for your analysis according to your column and your sample, considering the specifications of your column and your sample. Then effect of flow rate. So similarly, with changing flow rate, how we can change the flow rate? Because we have a pump that is connected before the injector and column. So with the help of this pump, we can change the flow rate, mobile flow rate through the column. So what is the effect of flow rate on the analysis? So here you can see, so this analysis is performed at different flow rate, 1 ml per minute, then we have 1.5 ml per minute and 3 ml per minute. So what we can see from this figure, the retention time, column pressure and analysis time and resolution changes. So you can see retention time changes, the resolution also changes. So therefore the higher flow rate is not good for column, while the lower flow rate increases the analysis time. So here we have lower flow rate, but it increases the analysis time. So if we increase the flow rate, which is not good for the column health, the column will not last longer if we use very high flow rate. So the selection of optimum flow rate like temperature is also necessary. So these are the few important points I would like to highlight that most of the PhD student and researchers come across, and it is small problems. But if we don't understand that, then we cannot focus on our research and we cannot do proper analysis. So this topic is HPLC troubleshooting. So if you have some problem, how to find out while doing analysis. This is very important part. So after analysis, we should be able to understand the accuracy of analysis. So you have done the analysis, but you don't know how much accurate your analysis is. So then it is not important, right? So you should be able to understand that how much is the accuracy of your analysis. So sometimes we come across the baseline issues such as you can see here, the noisy baseline. It occurs when there is a contamination in the mobile phase or the mobile phase is not suitable. So if you see this type of baseline, you can change, sorry. If you see this type of baseline, you can change the mobile phase. There is some problem with the mobile phase. This is the normal baseline look like, and this is the noisy baseline. Okay, then another problem is peak drift. You can see this type of peak. This is due to unstable temperature or contamination of the column. So if you see this like this, then there must be a temperature problem either with the column or detector, or there is some contamination in the column. The incomplete peak, this is incomplete peak. If you see like this, it is due to high concentration of sample. So it is beyond the detection limit of instrument. If you inject this type of sample highly concentrated like 5% glucose, then you cannot see the peak. You will see like this, the half peak. So in that case, you have to decrease the concentration of your sample. You have to dilute your sample before analysis. Then we have peak tailing and peak fronting issues. The peak should be sharp, as I shown in previous slide. If you see like this peak, there is some problem with your analysis. This is called peak tailing. You have a tailing here, and this is called peak fronting. We have peak fronting here. The peak tailing this issue happens due to improper mixing of mobile phase or problem with the column. And the peak fronting usually happens due to overload of sample or lower analysis temperature. So you have to understand these problems and find out the solution if you come across to have a higher accuracy in your analysis. So So at the end, I would like to highlight on some advantages of HPLC analysis, why we use HPLC analysis. It has a high sensitivity, high performance, rapid analysis, quantitative and qualitative analysis. We can do both analytical and preparative purpose, and analysis of complex mixtures also we can do, and versatility in analysis. So HPLC has a huge potential due to the possibility of selection of various mobile phase, stationary phase, depending on the type of analysis, and this make this analysis highly versatile. Okay, and more importantly, because if you want to use gas chromatography, there what you are doing, you are vaporizing sample. The analysis happens in the gas space. But in HPLC, you don't have to do that because there are some samples which have very high boiling point. You cannot vaporize them at 200 or 250 degrees Celsius. So in that case, you can use HPLC. So it is highly versatile technique, and we can do analysis of almost all types of liquid samples. So that's it. So that's it in this presentation, and thank you for listening. If you have any questions, so I will be happy to answer. Yeah, thank you.
Thank Okay, thank to nhỏ này. Thank you, Dr. Saga, for giving us the nice speech. It's very useful information for us and for our students. So let's come to part question and answer. Hi everyone, do you have any question?
Yeah, if you have any question, simple question, difficult question, whatever it may be, you can ask, no problem. I will try to give answer. Yeah, I will try to do my best. Actually, I kept this talk very simple so that all students can understand it, because there are very advanced part also. So I didn't touch that so that it's easy to understand. So I just kept this like as simple as possible.
Yeah, I think that's very useful. This is enough for us. Okay, any question? Okay, I got one question from my student.
Okay, go ahead.
For example, if we have one picture, there are like three components, but two of them, they have very similar property. So I mean, can we use HPLC for analysis that?
So you mean similar property means which similar property you want to say? Like
Like,
glucose and fructose are similar, right? Both are
yeah.
sugar, both are polyhydroxy compound. So that means, or you want to say like similar properties in terms of other properties like physical property. Of course, we can use HPLC for even if compounds are highly similar. Like as you know, glucose and fructose has the same molecular formula, same number of carbon, same number of hydrogen, same number of oxygen. Just the arrangement of molecule is different, right? But still we can separate both compounds using HPLC. Just we have to use the detectors columns accordingly. We have to choose. We cannot use C18 column for the analysis of sugar. We have to use the acid column, or maybe the we have to use a normal phase HPLC. And for the separation, we have to select the detector as a RI detector, because the compound cannot absorb the light. It don't have a conjugation. It is not having chromophoric group, right? Then we have to use RI detector, and then we can do the separation. No problem. We can use the HPLC for compounds with similar properties.
Okay, thank you. I will translate for them.
Yeah, no problem.
Okay, there. Maybe there are no any question.
Okay.
Okay, finally, thank you, Dr. Saga, for give us a nice speech.
Yeah, my pleasure.
Okay, maybe thank you. I will someday I will come to Taiwan and see you.
Yeah, no problem. I'm very happy to see you. Yeah, no problem. You're welcome.
Okay, bye bye.
Okay, bye bye. Thank you. Bye bye. Yeah, bye bye. Thank you. Bye bye.
Chụp hình không? Chụp hình không? Wait minutes. Wait minutes.
Yeah, no problem.
Can you open the webcam? We can take the picture.
Yeah, sure.
Okay. À, thấy mở trên này tụi nè, xe cái màn để xe.
What happened? Just give me one. Hmm. Hello.
Hello.
I cannot see. I cannot see that option camera now. I don't know why. Just 1 minute. Let's see
Okay.
again.
Tí nữa mình chụp trên này cũng được.
Can you see me? Yeah.
Still not yet.